Welcome to the heart of the AEON-CASIMIR Initiative, where the boundaries of propulsion physics are being redefined. In this chapter, we move beyond traditional rocket science and explore how spacetime itself can be shaped and manipulated for movement. The focus is on vacuum, metric coupling, and stress-energy control, concepts that form the mathematical core of the AEON-CASIMIR propulsion system. By understanding how vacuum energy and boundary conditions interact, we unlock new possibilities for movement without conventional thrust. Let's begin our journey into the science that could change how we travel across the cosmos. In quantum field theory, vacuum energy isn't just empty space. It's a dynamic field whose density can be altered by the boundaries we impose. When electromagnetic modes are confined between structured boundaries, the allowed energy spectrum changes. This means that by engineering these boundaries, we can locally increase or decrease vacuum energy density. This isn't just theory, it's the experimentally verified Casimir effect. Through careful design, vacuum energy becomes a controllable field, opening the door to new forms of propulsion and energy manipulation. The Casimir vacuum doesn't just sit passively, it actively shapes spacetime through its stress-energy tensor. This tensor includes both the Casimir energy density and the anisotropic vacuum pressure, which is influenced by the geometry of the boundaries. In the AEON-CASIMIR system, these pressures are not uniform, they are directional and can be engineered to produce specific effects. This means we can sculpt the curvature of spacetime itself, a crucial step in achieving propulsion without traditional thrust. Key innovation in the AEON-CASIMIR approach is the separation of vacuum modes into positive and negative energy sidebands. By phase-locking these sidebands, the system can control the net vacuum stress-energy tensor. This process doesn't create exotic matter. Instead, it redistributes vacuum stress within strict relativistic limits. The result is a powerful tool for manipulating spacetime curvature in a controlled and reversible way. AEON-CASIMIR system modifies the classic Einstein field equations by adding a Casimir term. This term introduces engineered curvature gradients that are localized to the vehicle. By including matter, plasma, and Casimir contributions, the equations describe a system where spacetime curvature can be precisely controlled. This mathematical framework is essential for understanding how the propulsion system operates at a fundamental level. Boundary geometry plays a direct role in shaping the stress-energy tensor. By adjusting parameters like metamaterial properties, cavity separation, orientation, and phase timing, the system can dynamically sculpt spacetime curvature. This allows for real-time control over the propulsion environment, ensuring that energy conditions are respected globally while enabling local manipulation. The ability to fine-tune these boundaries is a cornerstone of the AEON-CASIMIR architecture. The concept of a warp shell in AEON-CASIMIR is distinct from the well-known Alcubierre metric. Here, the warp shell is defined by a metric index envelope, which acts like a refractive index for spacetime. This envelope redirects geodesics, reduces external coupling, and enables inertial decoupling. Importantly, the refractive index is nearly 1 everywhere except near the vehicle's hull, ensuring stability and safety. At the boundary of the vehicle's hull, stress gradients are carefully smoothed using a vacuum slip layer. This innovation prevents atmospheric shock, shear heating, and electromagnetic coupling signatures. As a result, the craft becomes effectively transparent to its surrounding environment, minimizing disturbances and enhancing stealth. This slip layer is a critical feature for both performance and safety. Despite the advanced manipulation of spacetime, energy is always conserved globally in the AEON-CASIMIR system. Local changes in curvature are balanced by plasma energy storage, vacuum mode redistribution, and field phase cycling. The Casimir energy naturally scales with cavity separation, enforcing strict limits and preventing runaway solutions. This ensures that the system remains stable and predictable under all operating conditions. One of the remarkable features of the AEON-CASIMIR approach is its consistency with established physics. At large scales, Newtonian gravity emerges as expected, planetary orbits remain stable, and the cosmological constant is unchanged. The system operates far below the thresholds that would affect the universe on a cosmological scale, ensuring that local propulsion does not disrupt the broader fabric of spacetime. The practical results of this coupling architecture are profound. The AEON-CASIMIR system enables lift without thrust, translation without momentum exchange, and shielding from inertial stress. It operates nearly silently and remains stable across scales ranging from the nano to the cosmic. These operational advantages make it a game-changer for advanced propulsion and transportation technologies. Chapter 2 firmly establishes that vacuum energy is not just a background field, it is a controllable contributor to gravity. By engineering Casimir stress into directional tensors, we can shape spacetime curvature locally and reversibly. This transforms propulsion from a force-based phenomenon into a geometric one, where movement is achieved by altering the very fabric of space. The ability to engineer Casimir stress into specific, directional tensors is a breakthrough for propulsion technology. This approach allows for precise control over the direction and magnitude of spacetime curvature, enabling new forms of movement and stability. The mathematical tools developed in this chapter lay the groundwork for future advancements in the AEON-CASIMIR system. Key advantage of the AEON-CASIMIR approach is the ability to shape spacetime curvature locally and reversibly. This means that changes can be made in a controlled area without affecting the broader environment, and those changes can be undone as needed. This flexibility is essential for safe and effective propulsion, as well as for potential applications in other areas of physics and engineering. Perhaps the most revolutionary idea in this chapter is the redefinition of propulsion as a geometric phenomenon. Instead of relying on force and momentum exchange, movement is achieved by altering the geometry of spacetime itself. This shift in perspective opens up entirely new possibilities for travel and exploration, both within our solar system and beyond. The mathematical framework established in Chapter 2 is not just theoretical, it is the foundation for all subsequent developments in the AEON-CASIMIR system. The equations and concepts introduced here will be built upon in Chapters 3 through 10, guiding the design and operation of advanced propulsion technologies. This chapter is the keystone of the entire initiative. With the completion of Chapter 2, the AEON-CASIMIR team has locked in the core principles of vacuum, metric coupling, and stress-energy control. The groundwork is now set for the next stages of development, where these concepts will be translated into practical engineering and operational protocols. The journey continues, but the mathematical heart of the system is now firmly in place. The AEON-CASIMIR Initiative, based in Northwest Indiana, is at the forefront of propulsion research. Led by Colonel James Hartman, the program is dedicated to exploring the frontiers of field architecture and vacuum energy manipulation. This chapter is just one part of a larger effort to revolutionize how we think about movement and energy in the universe. Boundary engineering is more than a theoretical concept. It is a practical tool for controlling vacuum energy. By designing and manipulating the boundaries that confine electromagnetic modes, researchers can directly influence the behavior of the vacuum field. This hands-on approach is central to the AEON-CASIMIR system and represents a major step forward in applied physics. The principles outlined in this chapter have far-reaching implications for the future of transportation, energy, and even our understanding of the universe. By mastering the control of vacuum energy and spacetime curvature, humanity could unlock new modes of travel and exploration. The AEON-CASIMIR initiative is paving the way for these exciting possibilities. As we conclude Chapter 2, it's clear that the AEON-CASIMIR system represents a paradigm shift in propulsion physics. By harnessing the power of vacuum energy and mastering the art of boundary engineering, we are on the cusp of a new era in movement and exploration. The next chapters will build on this foundation, taking us deeper into the practical and operational aspects of this revolutionary technology.